I've just bought 5 extra minutes. Is that going to work for you if we just go a few minutes after? You've got to go. Go. How it is. So we're going to think about doing botany. We'll do it and you just watch the videos. Is that the best way? Or do you guys want to just flag and do it tomorrow?
Is that the only one that's left?
This is the last one.
Oh, good.
Yeah. Botany. Biology is study of life. Logos. Botany is the study of plants. Ha. This is a fascinating one. When you plant a tree, it grows up. It starts from nothing or a seed, and there's all that wood and all those leaves. Where does the mass of the tree come from? Where? The ground? If you say the ground, then surely that mass has disappeared from the ground and basically the tree end up in a hole. Where does the mass of a tree come from? It's fascinating. The air. Carbon dioxide is in the air, and it's fixing of the CO2 molecules into C6H12O6 glucose molecules that causes the sugars and the fibers to be created. So the tree literally comes out of the air. Yes? Amazing. All plants are basically the air frozen.
And is that why when you burn it, it goes back into the air? CO2.
So when you're having a fire, the energy of the sun is trapped by the plant. And then you have a fire in your fireplace, and you're feeling the sun from another summer's day.
It's
So cool.
Wow.
When you burn wood, you're feeling the sun from another summer's day.
It's like time travel.
It is, it really is. Yeah. It's rather poetic, it's rather beautiful. You will, tomorrow we'll look at photosynthesis, and I'll do the photosynthesis chart in a minute, but you'll understand that CO2 plus the presence of sunlight with chlorophyll, we need the green chlorophyll here, with water, creates oxygen as an output, C6H12O6 as glucose, and that's where sugar is. So, water, is there any point watering the leaves of a plant?
No.
Don't water the leaves, water the ground underneath, because water comes in from the roots, and I'm just about to show all of that. The sun, the leaves' job is to create sugar and protection and all sorts of other things. Oh, this one. It's hard for you to see. This is photosynthesis. This is the sun. This is a leaf. This is the xylem and phloem. The sun comes in and all the CO2 molecules here come into the leaf. They are separated into carbon and oxygen. O2s are put out this way. It was such a problem having too much oxygen in the air for a long time. That's that story I'd like to get to. I'll start off with tomorrow. There's the coming of, so exciting. The story of life is there. Too much oxygen is being produced by these plants. The carbon is taken with some of the oxygen, but some is taken out here. These are little, it's like a railway, and there's little trolleys. You can see it all set in here. Water is brought up from the roots, brought across. In the presence of sun, in a special place with chlorophyll there, they can change that carbon dioxide into glucose. Water plus CO2 gives C6H12O6 plus O2. Amazing. Amazing. Chlorophyll. This is such an exciting understanding of photosynthesis. And you know that chlorophyll is so important because in winter you start to see the chlorophyll, the green, fade from the leaves. And you see the carotene, the other colours that were already there, but you didn't see them before because the green covered them up. But the green comes out of the dead leaves, and we call this autumn. And we see the oranges and the yellows, which is the sign that carotene is there. Carotene is the same colour as carrots. In fact, that's where carrots get their name from. Carotene is this orange colour that is what leaves, all leaves are orange, except they have chlorophyll in them. Chlorophyll is necessary for photosynthesis. The sun worshippers. All leaves point to the sun. That's their point. They have to maximize their amount of ability to get to the sun. So all of them are, if you like, praising the sun. The worshipper. This is called the sun worshippers, this particular picture here. How does water get to the top of a tree? Okay, if we've just said the leaf needs water, but the water comes in the roots, how does water get all the way up those trees? How does water get up in a hotel? You're on the 6th floor, you flush the toilet. How does that water get up there? How the heck does it get all the way up that high? Now you're on the 32nd floor. Now you're on the 145th floor. How does water get up that high? A lot of engineering. A lot of engineering. All that way. You think how much the lift has got to work, and you're just humans. You're light. Imagine all the water that all those humans are using, and then it's all got to be used away. That in itself is stunning. So how does water get up a 50-foot tree? Well, the sun heats up the leaves. The leaves sweat, water evaporates off the top of the leaves. And when there's a vacuum, that sucks up more water from the roots. So the sun is literally sucking up water through the plant. I think that's rather poetic. I think it's stunning. The roots look out for the water. They're always seeking the water. Can you see there's water around these rocks? And all of these roots are heading off in this direction. The water falls off the tree like this fountain does, right? And where the water falls, that's where the roots are. And you can tell a lot by a plant's shape by where the roots are. Let's see, the water falls outwards on this one, getting wider. Where do you think the roots are? Out here. This one, the leaf shapes are quite different, and the water all falls to the middle. So where do you think the roots are?
In the middle.
Down here. This is like a carrot, right? All in one place. I talked before about the examples of where the roots are. Can you see it now? Where the roots are. So no point watering the leaves. You water in a circle around where the leaves are. This is where you water, and this is where you water. You got a comfortable glow. What does that mean?
It's really cool.
It's beautiful, isn't it? And then that's the feeling you want to get with the kids. Not when you guys are tired and can't bother at the end. It should be, wow. Absolute infinite gratitude for the wonderful world we live in and the sense of comfort that it's all there. And it works. And we understand that it's just beautiful. The roots have lots of relationships with the land. Here you can see that little people, like they've got mallets, and their soil holds the tree in place, right? It's sort of a stabilizer. The soil holds the tree in place. But here, a different picture, you see the roots are drawn as hands, and the roots hold the soil in place. So we need both. The soil needs the tree to hold it in place. The tree needs the soil to hold it in place. Take down the trees, you erode the soil. This is the pump system we talked about, and all it is, there's no actual pump in a tree, it's just very, very thin tubes that the sun is creating a vacuum by sucking off the water. Remember, that's how you breathe in the first place, so you have control over this muscle here, and when you breathe in, what you're doing is you are flattening your diaphragm, which causes a vacuum here, which causes a vacuum here, and so air rushes in. That's how you breathe in. Breathing out, you just relax it all, and air just finds its own, does its own thing. So remember, that's what you're doing, is creating a vacuum when you're breathing. Pump system of a plant. Look at how plants support themselves. Little tendrils go out, and they need extra support. They're just going to hang on. So they wrap themselves around. Amazing. You can do this experiment in almost 2 or 3 days. You'll see little tendrils worked their way around. And the fact that they're phototrophic means that they go to the light. Photo photo means light, trophic means moving, moving toward the light. Or they have little bows on them, and when they wrap around they can hold on to things, carry a lot of weight. You know what an Ivy League college is in America? Ivy League just means important or prestigious, and it comes from the fact that they have ivy on their old brick buildings because they're so well established. And so ivy is one of these plants that has little birds on it. Poison ivy is not so good to be consumed. You understand about how a plant reproduces. This is a flower reproduces. That we have the calyx here, we have the petals of the flower, this stamen. You can see it opens up, and there are different ways, you can see these over here, different ways that flowers present their pollen and stamen. This picture here is how the seeds get about. Well, you can actually see that the seed in this case is just like a little person, animated. Here we have like a cherry seed, and here is a plane. So the cherry seed is taken by birds or in the air and taken to other areas. This is a coconut, and you can see that the image is out on a boat, i.e. coconut seeds can float, and so that they can go around. These guys are helicopters, and here's a dandelion. Hey, dandelion. That is, isn't it? Yep, dandelion. You know, remember the time thing, i.e. they are designed to float through the air. And here we have them with birds, and he's hitching a ride. And it's this little picture of jumping on the back of a car, hitching a ride, and sometimes when you go camping and stuff, you've got birds on your shoes. Sometimes things explode out like this, and macadamias are an example. They explode in the heat. So how do seeds get about? Why do bees have hairy bottoms? So the bee is really, really keen on getting all of the nectar, which is just a sweet bonus juice. While doing that, the pollen is stuck onto the backs of their legs. Very, very important aspect of being a bee. The nitrogen cycle, you guys know that you need nitrogen because nitrogen is the basis of proteins. Nitrogen is very, very important for you for growth, for strength, for repairing cells, and a whole lot of other things. How do you get nitrogen? Well, nitrogen is in the air, but we can't take it out of the air. We have to take it out of the soil. So lightning will actually put nitrogen back into the soil. It comes through pulses. You know, pulses are chickpeas, a type of vegetable where that trap nitrogen. High in iron usually, but they also trap nitrogen through animals, feces of animals. Animals eat plants, the nitrogen cycle goes around, and you can start to see that we as part of the life cycle need to access other ways, use other animals to get the nitrogen out of the atmosphere so that we can use it. Monocotyledons and dicotyledons, most of you remember how the two different ways that plants reproduce. Some plants are both male and female. Some plants can change during their lifetime, and that we start off anywhere in the circle. We start off with a seed that grows and grows and grows, and here we can see that it is just multiplying, forms into a bit of a seed pod which breaks off, and then these little seeds are accepted in for a monocot. It's the same plant that fertilizes itself, and you can see the plant grows and grows and grows. This is a fern plant, and each of those seeds then is released in a way around. Somebody did their story on this, by the way. She used her 7th form biology notes. And the tree needs the atmosphere, needs the sun, needs water, and needs soil. Needs all of those. It's a lot of stories. A lot of stories, a lot for you to take in. There is no way you can take any of what I've just said in. You need to spend 4 or 5 hours just quietly going through them yourself and remembering what they're for, emailing me what's this one for, asking, or working out amongst yourselves. You will find them online, but there are a lot of stories there. Any thoughts on stories? Brain dead, everybody? That's what, sorry?
Well, it's actually very energizing. I didn't know that Australasia was just the opposite of Asia.
Australasia.
Because I was just like, oh yeah, it's like Australia, cool.
And you've heard of the Aurora Australis, which is the
Mhm.
southern lights. Aurora Australis and Aurora Borealis, yeah. Northern lights and southern lights.
There is
All good?
some, right?
Stories? Starting to get a handle?
In New Zealand,
Getting okay?
Yeah.
Go. Janet, you alright?
South Island.
very